Hi everyone, let's keep going. This is the second page of your Unit 3 test review, starting here with number 7. So this is a chain rule problem, and I just want to remind you that this is actually like a triple chain rule. I'm going to rewrite this a little bit. This really says cosine of 2x plus 1 with the cube on the outside. That's what it means when I have a cube written there. So let's start here. So I want f prime, right? Equals. Okay, I'm going to start with the furthest inside piece, which is the 2x plus 1. And the derivative of that is 2. And notice that I'm multiplying by the next piece. So that 2x plus 1 is inside a cosine. So derivative of cosine is negative sine. And usually we would say negative sine of x, but it's not an x. It's that thing that was circled in pink. That stays exactly the same. Times, and then my third piece out here is this power of 3, right? So that really covers all of this. And the derivative of a cube is 3 times the thing in parentheses, and then that's being squared. The thing in the parentheses is everything that was circled in blue a second ago. So that's going to be cosine of 2x plus 1. I may have closed off my parentheses a little early here. There we go. So as far as putting all of this together for a final answer, the way you would probably see this written is we would take the 2 and the negative sign and the 3 and put them all together and make a negative 6. And then I would have a sine of 2x plus 1 times a cosine. Oh, probably don't actually need those parentheses. Times a cosine. And this cosine is squared, so I'm going to put the square here of 2x plus 1. Okay. Now, if you didn't simplify it that way, or if you had it in a different order or something like that, that's totally fine. But that's what your process should look like. Okay. Number 8 is asking us for it's a second derivative, right? So I'm going to do this by hand. You could actually use that same Desmos method. I'm probably not going to take the time to show that here. But if this was a calculator question, you absolutely could get away with that. Remember that this is really cosine of x with a square on the outside. Okay, so let's talk about first derivative. First derivative is going to start with my derivative of the cosine, which is negative sine, times, and then I'm going to go to the outer function, which is the square, and that's going to be 2 times whatever. The whatever in this case is the thing that's circled in pink there. So it's the cosine of x. Okay. And then I am going to clean that up just a little because to do my second derivative, I want to try to make this look as nice as possible. So I'm going to write this as a negative 2 sine x and then cosine x. Okay, so the problem we're going to run into here when we go to do our second derivative, it's not really a problem, it just makes the problem a little more complex, is now I have a product on my hands. So I'm going to have to do some product rule here. Let's separate our u and our v. So this is going to be my u. And this is going to be my v. And then my u prime, let's say I'm just going to write this up here. So that negative 2, remember, can just stay part of my derivative. And then the derivative of sine x is cosine x. And my v prime would then be the derivative of cosine x, which is negative sine x. Okay, so let's write this out. So I'm going u prime times v. So that'd be negative 2 cosine x, that's u prime, times v, which happens to be another cosine x, plus v prime, which is negative sine x. Okay, I'm going to simplify this as I write it, so try to stay with me here. Negative sine x times negative 2 sine x. So my two negatives are really going to cancel each other out here. So I'm going to stick with this positive right here, but then I have a 2. So I'm going to say 2 sine x times sine x. Now, I'm really tempted right now to rewrite these. And if this is a multiple choice question, it could be written like this. But cosine x times cosine x is really cosine squared. And sine x times sine x is sine x squared. I think that that's harder to interpret when you write it that way when we go to plug a value in. So I'm going to just leave it like this, quite honestly, for right now. But let's go ahead and try what is this second derivative when I plug in a pi. So this is going to take me just a second to write out. It's cosine of pi. Maybe I will. I'm going to take that back just to shorten this up. This will really be like cosine of pi squared. That comes from the fact that I have 2 of these. I think we can handle that. And then 2 times sine of pi squared. So what I was saying a second ago is I could have written this as like cosine squared of x and then gotten rid of this thing, right? And sometimes when the notation is written that way, people have a hard time recognizing this interpretation. But if I just write it that way to begin with, we should be okay. Okay. So now this is negative 2. All right, cosine of pi. That's going to take a little bit of unit circle work. If you need to, pause the video and sketch yourself a circle. Negative 1 squared plus 2 times sine of pi. Sine of pi is 0 squared. Okay, well, negative 1 squared is positive 1, and then I'm multiplying by negative 2. This whole piece over here is going to cross out because of that 0. So I think I end up with just a negative 2 as a final answer. So if you got there, nice job. Okay, let's keep going. Next one's a tangent line question. And again, the good news is we have our point already, right? So all I really need here is my derivative so I can get my slope. So let's start with my derivative. All right, trying that again. Y prime equals, looks like I'm going to need some chain rule again. So my inside function is a 3x squared plus 2x. We did a problem like this earlier where my derivative is going to have 2 terms to it, right? It's a 6x plus 2, but I want to make sure I take that entire thing and multiply it by the next derivative in line. Now that next derivative is a square root, which remember is the same thing as saying something to the 1/2 power. So this would be a 1/2 times something to the negative 1/2 power. That something is what's circled in pink. So 3x squared plus 2x. Okay, so that's my derivative. I could clean it up just a little bit, and you saw me do this before. The 6x plus 2 can be on top. On the bottom, I'm going to put the 2 from the 1/2, and then a square root of 3x squared plus 2x. And I'm going to evaluate that at the point 2 comma 4. So now actually it's at the point 2 comma 4. But I also want you to realize that this derivative only has x's in it. So it's kind of the same thing as just evaluating at x equals 2. Either one of those would be correct notation here. But so I'm going to go 6 times 2 plus 2 over 2 times the square root of 3 times 2 squared plus 2 times 2. Oh, let's see how nicely this cleans up. So 12 plus 2 is 14 up top. And on the bottom, I'm going to have 2 times the square root of, that's a 12 plus a 4. Oh, so that's a 16. Okay, so I guess this doesn't clean up too badly. Clean that up just a little bit. Okay, So on the bottom, square root of 16 is a 4. So this is really a 14 over an 8 because it's 2 times 4 on the bottom. And then I can write my tangent line as y minus, I'm using my point up here, so y minus 4 equals 14 over 8, and then parentheses x minus 2. This would be a great one if this was on a calculator section to go and plug in this function to Desmos and plug in this equation and see if it's actually tangent to that function, because that's how you can check your work. Okay. So these next two are just dy dx problems. So I'm just going to dive in and start taking derivatives. And remember, every time I'm taking a derivative of y, I'm going to put in a dy dx and then solve for dy dx. In this first one, I have quite a bit of product rule going on here. So I'm not going to write out all the pieces individually. Maybe pause for a second and try this one on your own so that then you can compare with mine. So derivative of x cubed is going to be 3x squared. And then, so that's u prime times v plus v prime is dy dx times u, which is x cubed. So that right there is product rule for just this first piece. Okay, plus, now let's do this piece. So derivative of x is 1, and then times v, which is y cubed, plus. Now, on this one, pay attention to what I do here. So I know I need a derivative of y cubed, okay, which is going to be a dy dx, because it's a derivative of y. But then derivative of y cubed would normally be, it would be 3y squared. I'm leaving some space there on purpose. So what I have written there right now is v prime, right? But I also need to do v prime times u, which is the x. So v prime is this whole thing, and then I'm multiplying by the x because that's my u. I'm going to go ahead and just kind of squeeze that in here because it's multiplication. It doesn't matter what order it's in. And then since it's equal to a constant, I'm just going to say this is equal to 0 because my derivative of my constant is 0. So now I'm going to, just because it's less writing, I'm going to move the terms that don't have dy dx's to the other side. So minus 3x squared y, and put that over here. And minus y cubed, put that over here. Go on, go on. And so now I can write this left side as dy dx times, and inside these parentheses, I'm putting the things that are with the dy dx's. So that's going to be an x cubed plus a 3xy squared. That equals, over on the other side, a negative 3x squared y minus a y cubed. And then my last step would be just to divide. And I'm going to, instead of moving up and down, I'll just move to the right here. So now I'm going to say dy dx equals, the right side of my equation is still there. So negative 3x squared y minus y cubed. Oh, one space there. Sorry, guys. Okay, trying to squeeze this in here. Y cubed. And all of this is over that parenthesis, x cubed plus 3xy squared. So that whole giant fraction, that is your dy dx. That's what you were being asked to find, is your derivative. Okay, let's keep going. I'm going to slide this up some. This one is another dy dx one. I'm going to use a very similar method here. Derivative of x squared is 2x. I'm going to need a product rule, and I think this is now the third time that we've done this same product rule. Derivative of negative 2x is negative 2, and then times v would be y. And then minus derivative of y, which is dy dx, times u, which is 2x, plus, now 3y squared is going to get a dy dx with its derivative, and then 3y squared is 6y. Whole thing's equal to 0. Okay, just like a minute ago. I'm going to grab these things that don't have the dy dx's, and I'm going to move them to the other side. So minus 2x plus 2y plus 2y. Gone. So on this side, when I write this, let's just be careful here. I do have a negative here, right? I can also take that negative and put it inside with that 2x, and I think that might make this next step make more sense if we do it that way. So I'm gonna put a negative in here and make this a positive. It's okay, you can put it either place as long as you don't have it in both, right? But I want to be able to say that this side is dy dx, and then say what's left over. And this first one would be a negative 2x, and then I have a positive 6y. Equals, on this side, just to make life a little easier, because this is addition, I'm going to switch these around. You can if you want, you don't have to, but I'm going to write this as a 2y plus, nope, sorry, I meant to do a minus 2x, because I made the 2y positive, the 2x negative. And then last thing, of course, would be just to divide by that negative 2x plus 6y. Which gets rid of it over here. And that means over here, my derivative will just have a negative 2x plus 6y on the bottom. Okay. This next one, this has product rule in it. And I want to make sure you see what I'm seeing. Product rule, because I have multiplication right here. I'm going to have to use chain rule within product rule. Okay? So I will take the time to write out what my u and my v are. We'll do that over here. So I have a u, which is x squared. So u prime is 2x. Then v is inverse cosine of 2x. So v prime is derivative of 2x, which is 2 times the derivative of the inverse cosine. So derivative of inverse cosine is negative 1 over square root of 1 minus, and usually it's x squared, but in this case it would be the 2x being squared. And I'm going to clean this up just a little bit so it doesn't look so ugly when I put it in my derivative in a minute. I'm going to put the 2 up top. So I'm going to make this a negative 2 over a square root of 1 minus, and I'm just going to call this 4x squared. Save myself the parentheses. So in order to find v prime, I had to use chain rule. Okay, sometimes that happens. And sometimes inside chain rule, you have to do product or quotient rule. So these rules do kind of intertwine. Let me shrink this back up a little bit. Give us some space to work on our derivative. So now when I'm writing my f prime expression, I'm going to say u prime times v, right? So I'm going to say 2x times inverse cosine of 2x plus, now I'm a little space limited, so I'm going to go down below. My next one is going to be v prime, which is this thing, times u. And watch what I'm going to do with that. Since I'm multiplying by the x squared, I'm doing this fraction thing by the x squared, I'm just going to take this x squared and incorporate it up in this numerator. Okay, so I have a plus, and it is a plus, but technically this is going to be a negative. It's a negative 2x squared over square root of 1 minus 4x squared. Okay, so all of that together is your derivative. It's kind of segmented there, but let's take a look at this one on Desmos and see how we did. Okay, I think we can position this here and we can still see what's going on. So watch what I'm going to do here. I'm going to type in, and I do need my f of x again. This is very annoying to type in on this kind of keyboard. Like I said, it's not usually so bad on a regular keyboard. F of x equals x squared times inverse cosine of 2x. Okay, that's my function. Let's see, can we see it someplace? Oh, tiny little baby function. It just looks like that. That has to do with some of the restrictions on the inverse cosine. Okay, but that's all there is to this guy. And now what I want to do is type in the derivative. So I want it to tell me, what does f, oh, where is it? It's down here someplace. F prime of x look like. Forgot my parentheses. Okay, so that's what my derivative looks like. So now what I want to do is I want to type in my derivative. I want to type in what I came up with as an equation for my derivative and see if it looks anything like that. Okay, it should look exactly like that, like if we did this right. Okay, but let's take a look. So I have 2x times inverse cosine of 2x out here. I'm just going to write this as a minus because it's technically plus a negative. 2x squared divided by, oh good, that worked the way I wanted it to, square root of 1 minus 4x squared. Beautiful. That's exactly what I wanted to see. So notice this green one lays right on top of the blue one. So I'm kind of turning the green one on and off right now. The green and the blue graphs are exactly the same. So that's how you can check your answer to a derivative question. You can't get Desmos to tell you an answer like this. But once you have an answer, you can use this f prime to check it, right? You can check and see if they line up the same. And one more where we're just trying to find an f prime. This is just a pretty straightforward chain rule one. At least I hope. We're starting with f prime of x equals, inside derivative is the 3x squared plus 1, so that's a 6x, times, now my outside derivative is the inverse sine function. Inverse sine is 1 over the square root of 1 minus x squared, except it's not an x, right? It's what's circled there in pink. So it'd be the 3x squared minus 1. And realistically, the only simplifying I could see making sense here would be to put the 6x up on top. So we could write this as a 6x over square root of 1 minus, but I definitely would not take the time to FOIL this out. You could if you absolutely had to, but I don't think you need to. That would just be my derivative. And if I really wanted to, I could do that thing I did last time where I go down here to my little Desmos window that's hiding in the corner. I could type in the original, I could type in the new one, or I could type in the derivative and see if they match. Okay, that's about it for page 2. Lots of derivative fun there. Hopefully you're keeping up okay.